Swayam Prabha. Digital India. Educated India.
Hello viewers, welcome to lesson 4.8 which is on bituminous binders, which is the fifth in the series of lectures on pavement materials, and these are all part of pavement design module, which is module 4. The specific objectives of this lesson are to make the student understand the uses of emulsion in pavement construction, because in the previous two lessons on bituminous binders we discussed about different types of binders, that is straight run bitumen, cutbacks, different tests that can be conducted on bituminous binders, and some related parameters like aging concept of bitumens, temperature susceptibility of bitumen, and some fundamental properties of bitumen. In this lesson, we will cover another type of bituminous binder, that is emulsion, its uses in pavement construction, and we will also understand the need for using modified binders in pavement construction, learn how to characterize modified binders, how is the characterization different from that of other binders, and we will also try to understand the concerns or limitations of using modified binders in pavement construction, because of specific problems that can be there because of modified binders. We will start with bituminous emulsions. These have been developed first in the early 1900s. In 1920s, emulsions were used in pavement applications. That was almost the first known application of emulsion in pavement application, and these were initially used as dust palliatives to control dust problem. About 10 to 20% of all bitumen used in the form of bitumen emulsions, that is the world average, whereas in India we are using about 3% of the total bitumen that is produced, or rather that is used. The main applications of emulsions are in surface treatments, which is in the form of sealing the surface or micro surfacing the pavement surface and so on. Also in recycling, if you are trying to reuse the existing bituminous layer because it has become old, it has become distressed, cracks and other forms are there. So, that material is removed and reused. Before it is reused, emulsion can be added to rejuvenate that material, and then that would form a new bituminous binder. So, that phenomenon, that process is called as cold in place recycling. So, emulsions are used in recycling process also. The other applications of emulsions include maintenance patching, application of tack coat, application of prime coat. These are coats that are applied over existing granular base before a new bituminous layer is applied, over an existing bituminous layer before another bituminous layer is going to be applied on that. So, accordingly we have different types of coats that we applied over pavement surfaces, either on granular surface or on bituminous surface. If you apply it on granular surface, that would be prime coat. If it is applied on a bituminous surface, that is a tack coat. Obviously, emulsions can be used as dust palliatives. They can be used to fill the cracks in bituminous layers. They can be used as protective coatings, not of course, especially for bituminous materials, for other purposes. These are used in a construction called as surface dressing, also in bituminous mixes and for soil separation and other purposes. The main advantage of using emulsions, bitumen emulsions, is the conservation of energy and reduction in atmospheric pollution. This will appreciate once we understand what exactly emulsion is, how it is formed and how it can be used. Because with a bituminous emulsion, we do not have to heat it, normally we do not have to heat it. So, there is savings in energy. Also, there are no volatile matters that are coming into the atmosphere because of heating of bitumen, because of use of cutbacks. Most often emulsions replace cutback. So, as we indicated in the previous lesson, cutbacks were useful, but because of the problem of related to environmental aspects and also problem with safety concern, cutback is not normally used, but in its place emulsions are used. But besides replacing cutbacks, emulsions can be used for various other purposes also. With emulsion, it is possible to apply bitumen without heat and without dissolving it in a solvent. That is what we are doing in the case of cutback. In cutback, we were reducing the viscosity of the bitumen by dissolving it in a solvent, and thereby in a position, we are in a position to apply it to the pavement surface. So, without doing that and also without applying heat in bitumen emulsions, we can use emulsion without the additional need of heat or solvent. Basically, emulsion is a two-phase system consisting of bitumen and water, but it usually has one or more additives in the form of emulsifier. Bitumen is dispersed throughout the water phase. Basically, water is the main medium. Bitumen is dispersed in small particles in the form of discrete globules, which are of the size 0.1 to 5 micron, very small. So, these small globules are dispersed throughout the medium of water. The bitumen globules are held in suspension. If they do not remain in suspension, we cannot use this medium. If all the globules come together and then settle down, there is a separation of water from bitumen. So, it becomes bitumen again. So, the globules have to be, until this is applied, the globules have to be kept in suspension and free from one another. So, these are held in suspension in water and prevented from flocculating together and settling by electrostatic charges that are provided by the emulsifiers that we use in preparing the emulsions. So, emulsifiers have got a significant role in keeping the emulsion stable, keeping the bitumen globules in suspension, and thereby enabling us to use it. Emulsions typically contain about 50 to 75% bitumen. Ultimately, this is the bitumen that we are going to actually use. This is the bitumen that we are going to use to coat aggregates, coat any surface. So, all our calculations will have to be on the basis of what is the bitumen that is going to be finally available out of the emulsion, because water is going to go away. So, this is the bitumen that is going to be available, how much quantity is required to coat a given aggregate, given surface. So, the corresponding quantity of emulsion has to be used, and it may also have about 0.1 to 2% emulsifying agent. Obviously, the rest is water. These components are for producing emulsion. These components are introduced into a colloid mill, which operates at a very high speed. There is a high speed rotor. The operating speed could be 1000 to 6000 rpm, which shares the asphalt into tiny very small droplets. Emulsifier ions orient themselves onto the bitumen droplet and then provide the bitumen droplets electrical charge. It can be positive charge or negative charge depending on the emulsifier that we use. So, the bitumen globules get some electric charge because of the emulsifier, and that is what keeps them in suspension. So, the emulsifier keeps the asphalt droplets in a stable suspension. The emulsifier also controls the breaking time. We will discuss what breaking time is, and also aids in the adhesion also. Adhesion of the bitumen to aggregates or pavement surface. The emulsifier, they reduce the interfacial tension between water and bitumen, and they stabilize the emulsion by minimizing the coalescence of bitumen globules. This is what we have discussed in the previous slide, and the emulsifiers that we select influence the setting, are also known as curing rate and adhesion. Typically, the emulsion can be represented in a pictorial manner in this way. We have, if the entire thing can be considered to be water phase, we have bitumen globules, although they are shown very large in an exaggerated manner here, and on these globules you have emulsifier adhere onto it and then providing charge. In this case, it has got positive charge. So, there is positive surface charge for all these bitumen globules. So, obviously, in this case the emulsifier that is used is of that type which provides positive electric charge to the bitumen globules. As a result, all these globules have got similar charge, naturally they repulse each other. So, the possibility of their coming together and then coalescing or forming bigger particles is very remote or significantly less. So, this is what keeps these particles in suspension, because these are small particles, they remain in suspension. Unless they come together, they do not become heavy enough to settle down. When this emulsion is used on an aggregate surface having, let us say, negative charge, as you see here, let us say there is an aggregate surface. When it is applied to that, so the positively charged bituminous globules gets attracted to the negatively charged. If you have an aggregate having negatively charged surface, then this is the right kind of emulsifier to be used. The emulsifier that provides positive charge to the bitumen globules is the right kind of emulsifier to be used if we are going to use the emulsifier with aggregates having negative charge. Bitumen emulsions are normally classified usually on the basis of electrical charge surrounding the bitumen globules, which in turn is on the basis of the emulsifier that we use. Anionic emulsions have got negative charge particles, and these are suitable for calcareous aggregates like limestone, dolomite. On the other hand, cationic, which are positively charged aggregates, rather positively charged emulsion, these are most widely used. Cationic emulsion is the most commonly used emulsion in India and in many countries. These are suitable for siliceous aggregates like quartzite, sandstone, granite, and so on. There are non-ionic neutral emulsions also, but not normally used in pavement construction. If the emulsion contains negatively charged particles, as we just indicated earlier, the emulsion is anionic, as the particles would migrate towards the anode placed in the emulsion when electric current is passed through the emulsion. If we put electrodes in the emulsion and pass current through it, so the bitumen particles, because of their charge, will migrate towards the anode. That is why the negatively charged particles, emulsion having negatively charged particles is called as anionic emulsion. Emulsifier for anionic emulsions are usually fatty acids derived from mineral, vegetable or wood sources. Whereas, for cationic emulsions, the commonly used emulsifiers are amine salts. The emulsions can also be classified on the basis of how quickly the emulsion reverts to asphalt cement. Ultimately, asphalt cement or bitumen is what we want as our binder. So, the water has to go away. How quickly the water goes away and the bitumen coats the aggregates, that depending on the process that takes place, the emulsions are classified as rapid setting, medium setting and slow setting. Rapid setting aggregates emulsions are suitable for surface dressing and patch repairing. Medium setting emulsions are suitable for premix carpets with aggregates having lesser fines, whereas slow setting emulsions are suitable for premix purposes where we are using aggregates with larger percentage of fines. Similar thing we have discussed in the case of cutbacks also. If the amount of fines is more, that will accelerate the setting process or breaking process. So, in this case, so that will not permit actually sufficient coating of all the fine particles. If you have larger percentage of fine particles, then we have to allow sufficient time for the bitumen to be coating all the fine particles. So, the settling, breaking or curing has to be over longer periods. Though that is why as the percentage of fines increase, we are going for slow setting, slow curing, slow breaking type of emulsions or cutbacks. The bitumen emulsions are further classified as per Indian Standard 8887 2004, the most recent version, into RS1, RS2. Rapid setting are further divided into two different groups, and also slow setting are further divided into two different groups. And the uses are also identified. RS1 is to be used for tack coat, RS2 is used for surface dressing, medium setting emulsion is to be used for open graded premix having predominantly coarse aggregates. SS1, which is a slow setting variety type 1, is used for priming, fog seal and crack seal. SS2 is used for slurry sealing, seal coat and sand seal applications. These are mixes where containing larger fine aggregate contents. As I said, ultimately we need bitumen to be left behind and water should go away. So, the removal of water from emulsion is called as breaking. Breaking is a process which occurs through various phenomena. It could be electrochemical phenomena, it can be through evaporation, especially for slow setting emulsions. For dense mixes, the time needed for mixing, placing and compaction will also have to be assessed. Normally, rapid setting emulsions will have about 1 to 5 minutes of breaking time. So, if within 1 to 5 minutes bitumen can coat whatever surface it is supposed to coat, then rapid setting emulsion can be used. But medium and then slow setting emulsions may take considerably longer time. The type and concentration of emulsifier, because we have to also see what is the bitumen content that is available in the emulsion. So, the type and concentration of emulsifier controls the breaking time. In fact, we are referring to the emulsifier type of emulsifier that is used. So, that also controls the breaking time. Continuous complete loss of water and formation of continuous cohesive film is what we call as breaking. The water is removed by normally by evaporation. It can be by mechanical means, application of pressure, absorption into the aggregate. It normally happens faster under favorable weather conditions, such as the conditions that we refer to would be wind, temperature and humidity. The grade of emulsion that should be selected for a given purpose depends on the climatic conditions during construction, hot climatic conditions, rainy, cold climatic conditions. Accordingly, what would be the rate of curing, what will be the rate of breaking, and then what would be the time available before breaking occurs, curing occurs, and how much time is actually required for the bitumen to be coating fine aggregates, coarse aggregate. So, depending on type of aggregates, depending on climatic conditions, depending on the surface that is to be coated, and depending on the thickness of the film that has to be formed, also the construction equipment that we use to spray, to mix it and the roll and compact, and the traffic control that can be adopted in a given situation. If the pavement has to be opened very quickly, we have to go for quicker means. If you have time, we can go for slower one, because slow setting emulsions will always be better, because they are capable of coating the aggregates or surfaces more thoroughly. So, the selection of a grade of emulsion will be dependent on climatic conditions during construction, aggregate type and gradation, construction equipment to be used, and the traffic control methods or flexibility that is available at a given location. The main advantages of emulsions are they do not require a petroleum solvent to make it liquid. This is in comparison to cutbacks. In most cases, asphalt emulsions can be used without additional heat. These factors contribute to energy saving, because we do not have to use heat, we can save energy. Obviously, these are environmentally friendly, because little or no hydrocarbon emissions are there, because we are not heating bitumen, and there is no emission of solvents that we have in the case of cutback. So, there is little or no hydrocarbon emission. There are various tests that we normally conduct on emulsions. One of them is storage stability test, to identify how stable a given emulsion is going to be when it is stored, because most of the emulsions usually have certain specified shelf life. Certain emulsions will have to be used within 24 hours, other emulsions can be used within 1 week, within 1 month. Normally, the manufacturers specify the shelf life also. So, the emulsion will have to be normally used within that time period, otherwise the particles will coalesce, and then bigger particles will form, and then they will all start settling down. So, there is going to be separation of water and then bitumen. So, then once that forms, we cannot use that. So, in storage stability test, what we determine is the bitumen, the emulsion is settled for 24 hours, and the emulsion from top part and bottom part is obtained, and the bitumen from that is obtained from the top portion and the bottom portion separately. The bitumen is obtained by removing the water by distillation. So, the bitumen that is obtained from top portion and bottom portion, the content is compared. If there is no settlement at all, absolutely you should have the same bitumen content in both top portion and bottom portion of a container after 24 hours of settling. So, that is what is compared. Similarly, residue on a 600 micron sieve, the emulsion will be sieved through a 600 micron sieve. So, if larger particles, we already discussed that the emulsion globules or the bitumen globules are going to be very small, 5 micron, even smaller size. Unless you have larger globules forming, so nothing should be remaining on a 600 micron sieve. So, if we sieve the emulsion through a 600 micron sieve, depending upon how much quantity is retained on 600 micron sieve, that will tell us the amount of coagulation or the coalescence that is taking place. We are also interested in finding out what is the proportion of percentage of bitumen in the emulsion, because that is what ultimately is going to be useful for us. So, this can be done by distillation, removing all the water and then finding out what is the remaining bitumen. We also conduct tests for examining for coagulation. When we add this with water, whether there is going to be any coagulation of emulsion, that is another test that we do, and whether a given emulsion is cationic or anionic, we can also determine it by conducting particle charge test. This is to determine the nature of emulsion. The residue that is obtained from emulsion after distillation, that is the binder that is going to be used. So, obviously, there are number of tests that we do conduct on this residue, like we conduct on any other bituminous binders, such as penetration, ductility, softening point and so on. So, there are certain tests that are prescribed for the residue that is going to be obtained from the emulsion. These are the typical specifications for cationic emulsion. As I indicated, cationic emulsion is the most commonly used emulsion in India. For different types of emulsions, RS1, RS2, rapid setting 1, rapid setting 2, medium setting, slow setting 1, slow setting 2. The residue on 600 micron sieve, the matter that is retained on 600 micron sieve should not be more than 0.05%. Similarly, the viscosity determined using a Seybold-Frouhol viscometer at the specified temperatures should be within the range as indicated here. There should not be any coagulation at all when especially at low temperatures. The maximum difference in bitumen content from top to bottom from a storage stability test should be 2%, 1%, 1%, 2, 2 for different types of emulsions. And when tests are conducted on the residual bitumen, that is, the residue content should minimum be about 60%, 67, 50, 60. So, different quantities are specified for different types of emulsions. The penetration normally can range between 80 to 150 or 60 to 150, 60 to 350. These have been specified in terms of the typically produced slow setting emulsion 1, slow setting emulsion 2 and so on, and the binder that is normally used in producing these emulsions, the corresponding bitumen properties have been given here. The ductility should be minimum of 50 for all the residual bitumens that we get from these emulsions. We will next discuss about modified binders. On majority of our roads, conventional bitumens perform satisfactorily, but in special situations like highways having very high traffic intensity, highways having overloaded vehicles, airport pavements, facilities where we are going to have slow vehicles stopping, intersections, bus stops, loading unloading areas, parking areas where these vehicles are going to be in stationary condition for long durations. These are all special situations and they require special binders. Typically, normal binders have not been proved to be very satisfactory. Normal binders such as 80-100 binder, 60-70 binder, in many cases has not been found to be satisfactory. So, different bitumen binders are used to, or rather modifiers are used to modify the normal bitumen. Modified binders are nothing but bitumen modified by different modifiers. Various types of modifiers are available, accordingly various modified binders are available. Different modified binders are used to improve the performance of binders. Certain modifiers improve certain characteristics, other modifiers improve other characteristics. So, there is no one specific modifier that can be considered to be improving all aspects of bitumenous performance. Various binders as modifiers that are used are sulfur, natural rubber, crumb rubber obtained from discarded tire, old tires normally when they are retreaded. So, they are scraped and the small particles that come out of the tires, that is considered as crumb rubber. So, that is also added to bitumen to form what is known as crumb rubber modified bitumen. Various types of polymers: styrene butadiene styrene SBS, ethylene vinyl acetate EVA, high density polyethylene HDPE, low density polyethylene LDPE, polypropylene and various other types of modifiers. What these modifiers do to the binders? Main advantage of using these modified binders are: the temperature susceptibility of modified binders is in general much lower compared to straightened bitumens. That means, the properties do not change significantly with temperature variation. These binders have higher resistance to permanent deformation at higher temperature. In fact, this is the main purpose for which usually modified binders are used. Especially in India, we are concerned about failures that are occurring because of at higher temperatures and permanent deformation, rutting that is occurring in our bituminous mixes at higher temperatures. That is the reason in India mostly we are using modified binders. So, high resistance to permanent deformation at higher temperature is one aspect that we are interested in. These have better age resistance properties. With age, the degree of oxidation that takes place, degree of change of properties with time is much lesser in case of modified binders compared to normal binders. Similarly, these binders are generally known to have better adhesion to aggregates. The mixes have usually higher fatigue life, and there is also delay in the initiation of cracks, and also lesser reflective cracking problem is also there. How is the temperature susceptibility is going to be different in the case of modified binders can be explained using this diagram. What is presented here is the temperature versus penetration plot. The penetration on y axis should be on log scale, then only we can normally expect this to be a straight line relationship. So, if this is the line that we get for normal binder and this is the corresponding line that we get for modified binder, obviously we can see the line for modified binder is much flatter compared to the line that we have for normal binder. So, flatter the slope, we know it is less temperature susceptible, because over a temperature range the corresponding change in property is going to be much smaller for modified binder. If you examine the penetration that is obtained at 25 degrees centigrade, this would be interesting. Both binders, let us assume, have same penetration. So, if we only consider the penetration value, we should assume that both binders are going to perform similarly, but consider the penetration values of both binders at higher temperature, that is 60 degrees centigrade, whereas the normal binder has got higher penetration, modified binder has got lower penetration. That means, at higher temperature modified binder is much harder than normal binder. On the other hand, at lower temperature modified binder has got higher penetration compared to normal binder. So, normal binder would be much stiffer at 4 degrees centigrade compared to modified binder. So, we want the binders to be softer, not very stiff at low temperature, and they should not be very soft at high temperature. This is a property that is normally attained by modifying bitumen. These modified binders are also normally known to improve the fatigue performance. This is illustrated in this sketch. For example, there is a bituminous pavement and for a given tensile strain which is represented on the y axis, the two lines represent the behavior of the mix with normal binder and behavior of the mix with modified binder. The line on the right hand side represents the mix with a modified binder. So, for a given tensile strain, the number of load applications required to cause failure is much smaller in the case of normal binder, whereas it is going to be significantly larger with the use of a modified binder. But to use modified binders, there are certain requirements that have to be satisfied. The modifiers that we are going to use should be compatible with bitumen, because we blend them with bitumen, but they should not get separated after a certain time during storage, after use, various processes. So, they should not get separated significantly. So, that is what is meant by compatibility with bitumen. We should be able to blend them with bitumen. They should resist degradation at mixing temperature. We should not be using binders which get degraded, or we should not be using modifiers which get degraded at temperatures such as 150 degrees centigrade, and they should improve the temperature susceptibility of the bitumen. This is the fundamental purpose or main purpose for which we are using modifiers. They should also be capable of being processed by conventional mixing and laying equipment. Just because we are using modified binders, we should not be required to use different type of equipment, because simultaneously similar equipment is going to be used for constructing other layers using normal bitumens also. The use of modified binders generally gives rise to a coating viscosity at normal application temperatures. That means, they should have viscosity ranges at normal application temperatures. So, we should be able to use them at normal application temperature, and not that we should be using much higher temperatures for using these modified binders. And these modified binders should maintain their premium properties during storage, application and in service. The properties should not be changing significantly. Obviously, they should also be cost effective. Typical specifications for polymer modified binder, these are given as per IRC SP 53 year 2002. SP indicates special publication. So, this is a IRC special publication for which is specifications for polymer modified binders, elastomeric thermoplastic type polymer modified binder, that is PMB. There are normally 3 grades of PMBs that we use: PMB 120, PMB 70, PMB 40. So, the penetration range would be for PMB 120 90 to 150. The softening point for PMB 120 will be minimum of 50 degree centigrade. Ductility should be minimum of 75 centimeters for PMB 120, 50 centimeters for PMB 40. Obviously, PMB 40 is a much harder grade compared to PMB 120. Flash point 220 for all binders. Flash breaking point minus 24 for PMB 120, minus 12 for PMB 40. Elastic recovery is another property that we normally do not conduct for normal binders, but this is a test that we conduct on modified binders. We will discuss about this after a few slides. So, minimum value specified for this is about 75, and there is a separation test that is also conducted to find out how stable the mix is, whether there is a separation of modified from the bitumen. So, there are 2 different parts of bitumen that is collected, softening points are tested, the difference should not be more than 3 degrees. How to conduct separation test also we will briefly discuss subsequently. The viscosity of this modified binder conducted at 150 degrees centigrade should be in the range of 1 to 3 poise for PMB 120 binder and 3 to 9 for PMB 40 binder. Further characteristics that are normally determined for these modified binders are by conducting TFOT test, thin film woven test. So, after the binder is subjected to TFOT, we determine the loss in weight, this should not be more than 1%. We determine the increase in softening point compared to the original binder and the aged binder, the value should not be 7 more than the increase in the softening point should not be more than 7 for PMB 120, more than 5 for PMB 40. The reduction in penetration should not be more than 35. The elastic recovery of the thin film woven aged bitumen should be a minimum of 50. Similarly, we have specifications for other types of polymer modified binder, which are known as plastomeric thermoplastic. These are further specifications for plastomeric thermoplastic type polymer modified binder. These are the specifications for natural rubber modified binders, that is NRMB. We can see here NRMB also specified in terms of 120, 70 and 40 grade. The corresponding penetration values similar to what is given in the case of PMB is there. Softening point minimum is 50, 55, 60. Frost breaking point minus 20, minus 16, minus 12. Ductility 75, 60, 50. Elastic recovery 50, 40, 30. We are requiring much lesser elastic recovery. In this case, the separation difference is a maximum of 4 for all these binders. These are the TFOT requirements on the TFOT residue. Reduction in penetration should be a maximum of 40%. Increase in softening point should be a maximum of 7, 6, 5. Elastic recovery on the residue obtained after TFOT test should be 35, 30, 25 for these 3 binders. Similarly, we have specifications for crumb rubber modified binders. These are the binders obtained by blending crumb rubber that I have just discussed previously, which is obtained from old used tires, which can be from which those steel fibers or other fibers can be removed, and it can be shred and then made into fine powder form or even smaller particles, which can be added to bitumen, and then the appropriate under appropriate conditions it can be blended. So, those binders, it has got different grades CRMB 50, 55 and 60. The specifications are 70 penetration, 60 penetration, 50 penetration, but the specification 50, 55, 60 as you can see is in terms of softening point. The softening point should be minimum of 50, minimum of 55, minimum of 60 for CRMB 60. Similarly, other specifications are available in special publication of IRC 53. Let us examine the criteria that we have to adopt for selecting an appropriate modified binder for different conditions. Usually, these are based on atmospheric temperature. On the left hand side, we have minimum pavement temperature ranging from minus 10 to plus 10, more than 10, and on the upper row we have maximum atmospheric temperature less than 35, 35 to 45, more than 45, and various combinations of modified binders that can be used are listed here. For example, we have a location where maximum atmospheric temperature is more than 45 and the minimum atmospheric temperature is more than 10, then we can examine PMB 70, NRMB 70 or CRMB 55. Whereas, you have maximum temperature of 45 and minimum temperature less than minus 10 degree centigrade, the binders that are considered suitable are PMB or NRMB 40, these are harder grades, and CRMB 60, this is a harder variety of CRMB binder. There are certain issues that we need to be concerned about when we use modified binders. These binders should not be heated excessively, as it may result in degradation and rapid oxidation of the binder, and the modified binder may also lose its important properties. Strip mix may be formed, causing difficulty in rolling. So, excessive heating should be avoided as far as possible. Also, we should not be heating this binder repeatedly, multiple heating should be avoided. Also, if we try to use excessive quantity of modifier, either crumb rubber, natural rubber or polymer, this may cause the difficulty in mixing. So, normally there is an upper limit of on modifier that can be added to binder is also normally specified, either rubber or polymer. It is also necessary that thorough blending of modifier with bitumen is to be ensured. This can be ensured by conducting a separation test, because the crumb rubber should not be floating in bitumen, polymer should not be seen separately. So, as far as possible, the best possible blending should be obtained. Modified binders supplied in drums or bags shall be agitated in molten condition. These are usually specifications given by the manufacturer before the material is used. They would tell you that what are the conditions to be followed, to what temperature it has to be heated, how it has to be remixed again if it is required, then that is how the binder has to be used. We have to look for the manufacturer specifications, especially if NRMB, which is supplied at 130 to 150 degrees centigrade, normally it has to be supplied at the temperature, should be used within 24 hours of its filling. Side blending, many cases the blending of rubber with bitumen, blending of polymer with bitumen is permitted, but this should be done close to the hot mix plant using only appropriate mobile unit. The temperature of mixing and rolling shall be slightly higher compared to conventional bitumens. When we are using modified bitumens, all the temperatures normally related to mixing, rolling and other things will be slightly higher compared to the temperatures that we maintain for normal mixes. We talked about two different tests. One is elastic recovery test, we specifically conduct for modified bitumens, and also separation test. We will first start with elastic recovery test. This is very important for bituminous binder to recover after removal of load, that is load that is caused by application of wheel loads. The inability to recover results in permanent deformation. If it cannot recover, that means permanent deformation, that leads to rutting. So, we want the binders to be having sufficient ability to recover once the load is removed, that is reflected in terms of elastic recovery. The elastic recovery test is for determining the ability of binders to recover from a stretched condition. What we do is we use standard ductility operators to conduct this test. After the sample has reached a specified elongation, it is cut and allowed to recover. Slightly modified briquette is used. In this case 10 by 10 millimeter, same size is there, but it is not at one location, it is over some distance. So, this briquette is stretched at same rate of stretching as we do in the case of ductility, 5 centimeters per minute. So, this is extended by 10 centimeters at a rate of 5 centimeter per minute and cut. After 1 hour, we examine that there is some amount of recovery. So, these two briquettes are parts of briquettes are brought together, its dimension is measured, that would be known as x. So, elastic recovery is calculated as 10, that is the total extension, minus x divided by x divided by 10 expressed as percentage, that is obtained by multiplying by 100. The separation test is done by storing the modified binders at elevated temperature. So, storing modified binders at elevated temperatures can cause the constituents of the binder, especially those modifiers that we are added to the binder, to separate, resulting in variation of properties from top to the bottom of the storage tank. So, on storage there could be some separation, especially if the binder is stored at elevated temperature. So, if you collect a sample from top, collect a sample from bottom and determine its properties, they can be significantly different if it is a binder which is prone to significant separation. Storage stability test is meant for evaluating the susceptibility of binders to separate. What is done is the binder is filled in a tube and stored in for a period of time, specified period of time in an oven at a specified temperature. The tube is frozen so that it can be cut into 3 pieces, 3 equal pieces. The properties of the binder collected from the top part of the tube and bottom part of the tube are compared. On the left hand side, let us consider that to be a tube, vertical tube, which is filled with bitumen. About 50 grams of binder is used. The ends of this tube will be sealed. It is kept vertically at 163 degrees centigrade in an oven. It is kept like that for 2 days. After that, it is taken out and kept in a freezer at 6.7 degrees centigrade for 4 hours. Then this bitumen becomes quite hard, and now the tube can be cut into 3 parts without the bitumen coming out. Size of the tube that has to be used is also indicated here. So, after it is cut, you see those 3 parts. So, the material that is taken from the upper part and the lower part will have to be extracted, and it has to be tested. As we have seen in these specifications, especially it is the softening point that is used as an indication of what is the difference between the softening point obtained for the upper part bitumen and the lower part bitumen. That comparison, in several cases the difference should not be more than 7 degrees, other cases the difference should not be more than 4, 5, different values are specified for different types of binders. To summarize, in this lesson we have so far learnt about the role of emulsions in pavement construction. We also try to understand the need for using modified binders in pavement construction, especially when there are special situations like heavy loading, high temperatures, even very low temperatures, large temperature variations, standing loads, and other special conditions. These are conditions where normal binders have been found to be not normally been very effective. So, then we may have to go for modified binders. We have also learnt about how to characterize modified binders, how the characterization of modified binders is different from that of normal binder. We have discussed the issues or concerns pertaining to the use of modified binders. Let us take a few questions from this lesson. Answers to these will be provided in the next lesson. What do you understand by emulsion? What are the main tests to be conducted on emulsions? Number 3, what are the situations that may require use of modified binders? Number 4, how are modified binders superior to normal binders? 5, what is the significance of elastic recovery test? 6, what is the significance of separation test? Now, let us take up the answers for the questions that we asked in lesson 4.7. The first question was, what is kinematic viscosity and what are its units? We have seen absolute viscosity is the fundamental property, rheological property of bitumen, but it does not really take into account the inertial force. So, it has been seen to be convenient to use the ratio of viscous force and the inertial force. So, that is what is kinematic viscosity is about. It is absolute viscosity divided by the density of the fluid. Its units are usually in terms of meter square per second. In Celsius units, it is also expressed in terms of Stokes, but more commonly it is expressed in terms of centi-Stokes. The second question was, what is the difference between short term aging and long term aging? In the case of bitumens, they are subjected to various operations, various processes while it is used, while it is mixed with aggregates, and also while it is in service. So, these binders undergo aging. The aging that occurs over a short time period during initial mixing, storage, transportation and laying process, that is a very short time period. So, the aging that is occurring during that process is called as short term aging. On the other hand, during the service life period, the aging that occurs because of various parameters during service life period, this could be over 5, 10, 15 year period, this is long term aging. The third question is, what is the significance of studying temperature susceptibility of bituminous binders? We need to understand this temperature susceptibility of bituminous binders, because we want binders that would perform satisfactorily at high temperatures, that would also perform satisfactorily at very low temperatures, the binder should not normally be very soft at high temperature, otherwise we will have problem of writing permanent deformation. It should not be very stiff also at very low temperature, otherwise these will crack at low temperature. So, this is the phenomenon that we are interested in, and that is normally obtained by conducting either penetration test or viscosity test at different temperatures and examining those plots. Next question is, estimate the penetration index value for a binder having a penetration value of 65 and a softening point value of 48 degrees. We already have the expression given in the previous class, which is I would dictate that penetration index is equal to 1952 minus 500 log penetration, which is 65 here, minus 20 times the softening point value, which is 48 here, divided by 50 times log of penetration, penetration value is 65 here, minus softening point, that is 48 here, minus 120. So, this expression can be used to work out the penetration index value. What are the commonly adopted systems of grading bitumen? Bitumens are normally graded in terms of penetration, in terms of viscosity, and also there is another system known as superpave gradation system, in which maximum service temperature and minimum service temperature are taken into consideration. Question 6. What does PG 64 minus 16 stand for? PG 64 minus 16 refers to a binder that would perform satisfactorily for a maximum service temperature of 64 and for a minimum service temperature of 16. Within that range, this binder is going to be satisfactory. What does MC 250 stand for? MC is a medium curing cutback, and 250 stands for viscosity of this cutback in centistokes at 60 degrees centigrade temperature. Thank you.